Image analysis. The opening and the closing of the gripper on our machine presents no serious problem, and the ability to detect the presence of the puzzle in the gripper during this process is straightforward because our application requires very little precision. Automatic garage door openers are able to detect and react to the presence of an obstacle in the doorway when closing. Even the problem of focusing the camera on the puzzle can be handled simply by designing the arm to position the puzzle at a particular predetermined position for viewing. Consequently, the first intelligent behavior required by our puzzle-solving machine is the extraction of information through a visual medium. It is important to realize that the problem faced by our machine when looking at the puzzle is not that of merely producing and storing an image. Technology has been able to do this for years, as in the case of traditional photography and the television systems. Rather, the problem is to understand the image in order to extract the current status of the puzzle, and later to monitor the movement of the tiles. This is a significant distinction from the activity of a television receiver that simply transforms the image from one medium to another with no conceptual understanding of the image. In short, our machine must demonstrate the ability to perceive. In the case of our puzzle-solving machine, the options as to what the images might be are relatively limited. We can assume that what appears is always an image of the puzzle, containing the digits 1 through 8 in a well-organized pattern. The problem is merely to extract the arrangement of these digits. For this, we imagine that the picture of the puzzle has been coded in terms of bits in the computer's memory, with each bit representing the brightness level of a particular part of the picture called a pixel. Assuming a uniform size of the image, the machine holds the puzzle at a predetermined location in front of the camera. We can detect which tile is in which position by comparing the different sections of the picture to pre-recorded templates consisting of the bit patterns produced by the individual digits used in the puzzle. As matches are found, the condition of the puzzle is revealed. This technique of recognizing images is one method used in optical character readers. It has the drawback, however, of requiring a certain degree of uniformity among the style, size, and orientation of the symbols being read. In particular, the bit pattern produced by a physically large character does not match the template for a smaller version of the sample symbol, even though the shapes are the same, and you can imagine how such problems increase when trying to process handwritten material. Another approach to the problem of character recognition is based on matching the geometric characteristics rather than the exact appearance of the symbols. In such cases, the digit 1 might be characterized as a single vertical line, 2 might be an open curved line joined with a horizontal straight line across the bottom, and so on. This recognition of the symbols turns out to be the process of extracting the features from the image being processed, called feature extraction, and comparing them to those of non-symbols, feature evaluation. This technique is not foolproof either, because minor errors in the image can produce a set of entirely different geometric features, as in the case of distinguishing between an O and a C, or in the case of the 8 puzzle, a 3 and an 8. We are fortunate in our puzzle application that we do not need to recognize and understand images of general three-dimensional scenes. Consider, for example, the advantage we have by being assured that the shapes to be recognized the digits 1 through 8 are isolated in different parts of the picture rather than appearing as overlapping images, as is common in more general settings. In a general photograph, for instance, one is faced not only with the problem of recognizing an object from different angles, but also with the fact that some portions of the object may be hidden from view. In short, the problems associated with a general image analysis are innumerous. Tasks that are performed quickly and apparently easily by the human mind continue to lie beyond the capabilities of machines. On the other hand, there are indications that alternative machine architectures may someday overcome the problems that elude us today.